This is Davika Academy. Today we want to look at Eigen values and basis for Eigen Space. If you have not subscribed to Davika, kindly subscribe, and remember also to share with your friends so that they will be able to catch what we are doing here. Most of studios here about pure mathematics and applied mathematics, and we all love maths. Let's go do it together. So if we have this transformation, that's a linear operator, then if you do that to the linear operator, then it will be also be linear. So it will carry its properties, so there will be no change. And if that matrix is singular, then its determinant will be zero. Similarly, if you have a given a matrix which is n by n matrix, then lambda being eigenvalue of a, this lambda will be the determinant of it will be the eigenvalue of a if and only if the determinant is for this matrix is 0. So if it happens that it's not 0, then you know automatically that lambda is not an eigenvalue. So basically, if you have told to find eigenvalues of a given matrix, what you need to do is generally get the determinant of this matrix, and if it happens is equal to 0, then you are just find that those will be the true eigenvalues of that matrix. Thus, to get the eigenvalues of a matrix, you basically need to solve this relationship. If you solve this relationship, then you are able to get the values of lambdas or the eigenvalues. Having noted that, we can look at some example. So let's find the eigenvalues and the basis of the Eigen space of this Eigen space. So basically, what we need to do here, we need to solve the equation that's the determinant of a minus r by I, and we are solving that equation being equated to 0. When you solve this, we will be able to get lambdas, which will be the roots, of course, of the characteristic equation, and which will be, by that fact, eigenvalues. Okay, so let's start working as we have just said. So if you do, remember, lambda I is basically, the I is the standard matrix. For this case, is n by n, which is 3 by 3 or 3. So our identity matrix is 1 0 0 0 1 0 0 0 1. This is our I. So that if you talk about lambda I, it's like we are multiplying this with lambda, in which case you'll find that this point here changes to lambda. And now we are substituting this, we are subtracting this from a. And if you do that, you'll get this being true. Now the determinant of that being equal to 0. How do you solve determinants? We basically multiply positives first. That So it is this part. Okay, then plus that to that gives you -4 plus the 3 here to here. That's again -4. That is using the main diagonal. Let's use the main diagonal now to get the other negative part. So we do negative that, hence this, then minus this and this. That's the reason you have this. Then minus this and that, and as we have this. So if solving this collecting like terms together, you'll find that this is true. And if you work out this one by using the relevant method for solving quadratic expression, remember I have also a tutorial on how to solve quadratic expressions of this kind of equations. So you can check it out from in this. You'll find that the roots are actually those. If you have a question on either of the how we solve this multiplication and so on, just leave a comment and I'll be able to demonstrate to you directly. Okay, you can have a class for you. Okay, remember to subscribe if you have yet not subscribed, and also share with your friends. Okay, now this gives us what we are calling the eigenvalues. Now let's look at the basis. How do you calculate the basis? You basically need to substitute your equation a minus ai lambda I. The lambdas now we know them. We have -2, so you are doing basically for the first one a minus 2. Remember, it becomes 2a. Now you have to solve that. So that when you solve this, you basically have this. So and the vectors that we have is x, y, z, like that. So solving and equating, you'll see we have this, which is same as this. And now in the vector now will be given by x. The y is x plus y, as you can see from the equation here, and equal to z. If you break this with the x's and z's, you can see that is true plus that. If you factor out x, you'll see we have that, you have this, and for z we have this. And these two now becomes our basis of the space, of the Eigen space. So this Eigen space here, you have these bases, those bases. So that is it. If you have a question on either of these points, kindly leave a comment, and also remember to subscribe and share also with your friends. And that's it for today.